Welcome to the webinar ISO 23875 New Cab Air Quality Standard, sponsored by CIM Magazine and Sy-Klone International with Climatrans, Polar Mobility Research Ltd, and in cooperation with the International Society of Environmental Enclosure Engineers. I am the organizer, Michelle Beacom, Managing Editor of CIM Magazine, and my co-organizer is Ryan Bergen, Editor-in-Chief of CIM Magazine. Just a little housekeeping before we get started. If you joined by computer audio, please make sure you've selected the computer audio button. If you joined by phone, please make sure you have selected the phone button. If you have any questions during the presentation, please type them into the question box in your GoToWebinar control panel. The questions will be held until the Q&A period after the presentation. We will have some poll questions during the webinar, so pay attention. Now I will turn the webinar over to Ryan to introduce today's presenters.
All right, thank you so much, Michelle, and thank you to everyone for joining us today. Today's presenters are Jeff Moordock, Project Lead for ISO 23875 with Sy-Klone International, Guillaume Lachapelle, Global Head of Health and Hygiene for Rio Tinto, and Austin Brown, Vice President of Sales and Marketing, Sy-Klone International. Thank you, gentlemen, for joining us. We're going to start with just a brief explainer on the standard. So we'll be right back after the video. So we'd like to begin this with a poll question. I believe Michelle's going to pull that up for us.
Jeff, are you talking? I can't hear you.
No, here I am. I'm sorry. Yes. First of all, I want to thank you. I want to thank CIM and I want to thank Climatrans, Sy-Klone, and Polar Mobility for making this possible today to have a conversation about something that is very near and dear to my heart and to the heart of many who are working in operator enclosures around the world today. We were very fortunate back in 2018 to be asked by Technical Committee 82 of ISO to develop a standard specifically around improving air quality inside of operator enclosures in mining environments. This was an exciting opportunity to do something about a problem that's been around for a long time. We put together a working group that was comprised of participants from 10 different countries, and we set about the project of determining what constitutes good air quality inside of an operator enclosure. And then we looked at the engineering control requirements that are necessary to provide that environment, and then what testing procedures might be necessary in order to validate the environment is actually producing the air quality that it is supposed to produce. And then lastly, we were very fortunate to have 6 industrial hygienists on the working group. Guillaume Lachapelle, who was one of the speakers today, was one of our working group members. So were 5 others from various companies around the world, and they contributed substantially to an understanding of how air quality in operator enclosures impacts the industrial hygiene processes at a mine site, and the kinds of things from an air quality perspective that they think, they know are important. We have had a very interesting dialogue going on between the engineering community and the industrial hygiene community as a result of their participation in the working group, which has proven to be invaluable. And really, to that end, the last thing that the standard was really concerned about was the occupational, or rather the integration of the machine on the work site. How is it going to be integrated, and what does that look like from a maintenance perspective, and what have you? So what I like to do is to go down quickly the things that are unique about the standard and give a short explanation about why these things are there. If we could go to the next slide. The first thing about the standard that's unique is that it is a life cycle standard. And what that means is that we're concerned about operator air quality, not just at the point of manufacture, but throughout the life of that machine. So the standard actually addresses not only the design, both the design on an OEM basis, but also on a retrofit basis. It also looks at the engineering controls which have to be incorporated into that design to give you good air quality. And then it performance tests. And then once it's validated that the engineering controls are giving you the air quality as a consequence of the performance testing demonstrating that, then there's an operational integration which really starts with the maintenance instructions which are provided and are required under the standard. It's very important that the machine is able to be maintained for the life of the machine in such a condition that the air quality that it provided initially can be maintained throughout the life of the machine. So there's an operational integration at that point when the machine is delivered from the OEM or from the retrofitter to the actual operator or the company that's going to be using the machine, and how they integrate that into their operations, which include the maintenance of that machine on an ongoing basis, and giving the ability for the industrial hygienist or the health and safety people to do ongoing audits of the cab to make sure that there's a continual performance of the air quality in the operator enclosure. So this actually addresses the operator enclosure from the time it's designed until it's put out of service at the end of its life. So this is unique in that it is a life cycle standard, and it involves all the stakeholders that touch that machine throughout its life cycle. One of the interesting things about it, it provides not only an opportunity to certify the cab in the beginning that it's conforming to the standard, but there's an ongoing recertification that can be done as a consequence of that operational integration and the desire to make sure that we have continuous air quality throughout the life of the machine. Next slide. So what I'd like to do is spend just a few minutes here and talk about the engineering control requirements that we have. And at a high level, there's 5 things that are in the standard. Some of these are things that you may have heard of before, which make a lot of sense, and some things are probably going to be new. One of them has to do with CO2 levels inside of the operator enclosure. One of the things that we notice as a consequence of the work that we've done previously is that CO2 levels can rise very quickly inside of an operator enclosure if there's insufficient fresh air coming inside of the operator enclosure on a continuous basis. The human body is continuously extracting oxygen from the air and replacing that oxygen with CO2. If there's not a replenishment of the oxygen in the air, that oxygen deficiency, which we recognize as a CO2 increase, as far as the standard is concerned, that's the way we're measuring it, causes the operator to suffer many things, anything from fatigue to completely blacking out, depending on how severe the condition is. So this was an issue that that we addressed head on. Candidly, this is new. There's not another standard out there that deals with an operator enclosures that's addressing the area of what is an acceptable level of CO2 in an operator enclosure, and then how do we ensure that that level of CO2 is kept at an acceptable level while the machine is operating on an ongoing basis. So that is a unique aspect of the standard. The second thing is, the second thing we're dealing with here, which is really critical path, since our machines are operating in high dust concentrations in mining environments, and candidly, while the standard is a mining standard in the sense that it was sponsored by TC82 Mining, and it's very true that it is a mining standard, but its applicability is universal as far as cabs are concerned. The cab, a mining cab and a construction cab on a wheel loader are essentially the same. The performance of the two, the performance requirements might be slightly different from a regulatory level, but from the standpoint of how you affect the controls, they're identical. So the standard equally applies across construction machines and any other kind of machine with an operator enclosure on it. Having said that, dust is a big problem. Some of the dust that we get involved in, fibrous dust, silica, these kinds of particulates are toxic. They can cause all kinds of problems with the human lung, which we want to prevent. So one of the key elements here is making sure that we have a recirculation filter and a recirculation system that will strip the particles out of the air when they're brought into the cab by the operator on his clothing or on his seat or on his boots. The second thing is we want to make sure that the air is brought into the operator enclosure in a high level of cleanliness, or in other words, it needs to be brought in as clean air. So we have a particulate filter requirement and a recirculation filter requirement, which are at a very high level. These are human respiratory filters. Traditionally, filters that have been used in operator enclosures have not been operating at this level of efficiency. So this is one of the benefits that we have here in addressing these two, the fresh and the recirculation airflow filtration. The next thing is maintaining cab pressurization, which simply means that we want to make sure that the cab is in a continuous state of positive pressurization. That allows the particles that come in the cab to be pushed out the cracks, but more importantly, because the airflow is always outward, and it keeps the dust from coming in the cracks and contaminating the cab. And lastly, we have to have a way to monitor what's going on inside of the cab. So there is a requirement in the standard for real-time monitoring that includes alarms as well as sensors for pressure and for CO2 that allow the operator to know on a real-time basis what the operating condition is or the air quality condition is inside of the cab. Next slide. I'm going to drill down very quickly here on each of these. The first one has to do with CO2 levels, and this is an interesting slide and an interesting approach. As we monitor the CO2 levels in the cab, as they go up, the oxygen levels are going down. So we want to make sure that we understand what is an acceptable level of CO2. And the working group this was the most intense discussion we had during the development of the standard. And it has to do with what's an acceptable level of CO2 in the cab. And the answer to that question is we are recommending that the ambient first alarm on the CO2 is set at the site, looking at the ambient level of CO2, what it is outside of the normal environment and the natural environment, and adding 400 to that, which is the amount that the operator is going to contribute up to. So we have a safety margin in there as well. So if the ambient level were 400, 400, and we have 400 for the operator, we would set the alarm at 800 as an example. And then we have, thanks to the IH interface with this committee, we came up with a 2500 ppm, which is the action level for CO2 as the second alarm level. That's the absolute alarm. That's when you've got to take action. So that's one interesting aspect of the standard, which is unique, having the two alarms and the ability to adjust those alarms, at least the first alarm, based upon site conditions. Next slide. The next thing we're going to talk about here really applies on the recirculation side. We're looking at how quickly the air is able to be purified or to be cleaned once the particles are brought in the cab and the door is shut and the system is energized. And the requirement, and this is unique, the requirement is that Once the particulate comes in the cab, we have a test here that says that within a 2-minute period of time, the air quality should, or the particulate concentration should be brought down to a level below 25 micrograms per cubic meter. And there's some good reasons for that, which we could spend time going into, but this would probably not be the best time because it's a longer discussion. But that is a unique aspect of the standard, that we are measuring in a performance test how quickly the particles are stripped out of the air that are brought in the cab by the operator. Next slide. The next slide is dealing with intake air filtration efficiency. We have adopted an ISO standard, ISO 29463, and we have modified that standard, changing the labeling requirements. That's unique. It's a high efficiency filtration standard for human respiration. That's a new thing as well, that this is being applied in this standard. And just bring that to your attention. There are labeling requirements. It is an engineering control requirement, and it's necessary to get certification on the cab as an ISO 23875 compliant operator enclosure. Next slide. We have a defined pressure requirement when the operator shuts the door and turns the key into the on position. Whether or not the HVAC is on or not, there's a 20 Pascal minimum requirement for cab pressurization. That means that the cab is always under a continuous state of pressurization when the operator's in, preventing the outside wind and particles from migrating inside the cab because there is no pressure inside the cab. So that's a minimum requirement. And we have a maximum pressurization requirement of 200. And we have a monitoring system that monitors that and alarms when you're below that level or when you're above that level. And that's also a requirement. The last slide is dealing with the monitoring, and which I've kind of gone through already. Real-time monitoring is a requirement in the cab in order to have certification. Obviously, if you're going to maintain air quality, you have to know what the air quality conditions are on an ongoing real-time basis, and that's the reason the monitoring requirement is in the standard. Now, having said all of these things, I'd like to go ahead and turn the presentation over to Guillaume. We're very pleased to have Guillaume here today, representing Rio Tinto, representing Workgroup 9, one of the contributors, IH contributors to the standard, and a friend. Thank you, Guillaume, for coming today. It's all yours.
Thank you, Jeff. Great introduction, great recap of the standard. And as Jeff said, I strongly believe, as an industrial hygienist and as a leader in the mining industry, that these standards can save lives, and we can actually reduce the exposure of our workers to an acceptable level where we won't, hurt the workers' life in the long run. As you know, exposure to silica or to any other type of dust could lead to different illnesses, and so who's going to benefit, from these standards? And we're working hard with, national and state and local government to adopt that standard. If it's introduced in the law, it's help us, to move forward and reduce exposure of our employees at the site level. It's a long run. Right now, we're working. If you go to the next slide, we're working more closely with different mining association and mining group, but it's a practical document. It gives, direction. It gives good information and good example on how to design the cab, how to do your performance testing, and how to maintain it all over the life cycle of the vehicle, because not every company can buy, brand new vehicle with ISO 23887 every year. So what the plan is work hard also with the actual machinery and retrofit it to meet the standard requirement. If you go to the next slide, like I said, it reduced the incidence of a long chronic health condition, and it established a requirement, and it can be also managed internally with your industrial hygienist. They have the expertise. If you have part of your team certified people that are, mastering the skills of the industrial hygiene, you can use them to read the standard and help you to make sure that your equipment will be ISO certified. if you want, you can go externally. That's also an option. But by having, you know, internal resources, they have all the expertise, and the standard gives all the details, so it can be used. It can be done internally. Of course, you know, it improves employee retention. Right now, it's most of companies have a difficulty to recruit people and keep people. If you have clean equipment, if you have nice equipment, I was lucky just 2 weeks ago to visit a mine site. Even though I'm based in Canada and there's like a lot of COVID restriction, I had to go on a mine site with them and talking to the operators. One thing is, you know, cleanliness and new equipment and new way of mining. People are operators are extremely engaged when you talk to them about those type of standards and those type of equipment. So it creates a safer workplace and creates retention, obviously, because people can move from mine to mine. But if they talk to each other and say, oh yeah, this type of mine, they have good equipment, it's well maintained, they take care about health and safety, and they have good work conditions. So it's important. Of course, it can lower the equipment maintenance costs. The AC system will run longer. It will reduce the dust. It will help to reduce the particulates building up in the evaporator part, so you don't have to change it on a regular basis. And most of company have already maintenance schedule and maintenance system. So if you include that in your maintenance schedule, and sometime in SAP or any other type of maintenance management system, you will be able to make sure that your cab is up to date, your cab is well maintained, and you include those requirements in your maintenance management system, and it will be done on a regular basis when it goes to the maintenance shop. And it's a consistent standard. Many mining company and many company that produce equipment were looking to have like one standard, and it's not perfect. It's not including everything, of course. There was a lot of discussion with all of the people. We have to make a compromise, but I think we have a good basis where we can build on, and there's other options that are coming in the future, maybe with improvement of the standard. So if you go to the next slide. So it provides, you know, like criteria with alert level of CO2, like Jeff mentioned, long-term prevent dust exposure. Most of the mining company or regulation around the world, you know, requires that you do sampling of the workers on a regular basis, that you take a chest X-ray, that you have like dust separation system, that you have double lockers if your workers are exposed to asbestos, for example, or different contaminants. But it's all part of a global reduction program to make sure that your employee have a better breathing area when they're working either underground or above ground, because we've done, and I think we're going to share it a little bit later, we've done some retrofit of Pit Viper in open pit, and it drills, and it worked well. So, and it demonstrates a commitment, a real commitment towards health and safety. And I know in most of the mine we talk a lot about safety, and safety is like super important, and collision between equipment, you know, falling object, and all of those. But when we start talking about health and hygiene, we need to create those examples of good practices. And this is one, it's not easy, but it's one that you can achieve by retrofitting a couple of your equipment and showing your workforce that you're really taking care. And the ultimate goal is to create that, is to reduce exposure and have, you know, a better way to manage those dust in the work environment. If you go to the next slide. So like I said, it's part also of discussion at ICMM. So ICMM is most of the big mining company, part of it's the International Mining and Mineral Council. Rio Tinto is part of that, BHP, Valley. So all the big Glencore, all the big mining company are part of that. I made a presentation at the health group over there a couple of weeks ago. There's other discussion that's been done at EMER, so it's an earth moving material roundtable. So there's discussion around that, and so and we're all there. You know, those organizations, ICMM, and the different organization of mining that can help you and give you tips and assistance, and company like Sy-Klone have done it. There's other company that also have you know, the expertise to retrofit your equipment. So it's available, and you can contact them. You can contact me. You can contact Jeff, and we will help you to start the process and implement it in your area. If you go to the next slide. And we've talked about it, you know, reputation, values of your company, and working, you know, most of, and I like that, you know, coming back to the hierarchy of control. Most of you have seen that, you know, from elimination to PPE, and most of the time we're very focused on PPE, and we're just like, hey, let's give more PPE, or let's give, you know, better PPE. But by having those engineering control, you know, they're more efficient on the scale of the hierarchy of control. And at one point, you know, substitution and elimination is very difficult in mining. So some mine, they have asbestos in there, or even though you're mining for gold, you might find asbestos, or nickel, you might find asbestos part of your ore. You have silica. So it's very difficult to do substitution or elimination. So you have to be really, really good at engineering controls, and in this standard, it's helping you to lead to that. So and the regulator will come at you and will ask you, what are you doing to reduce exposure? And you say, oh yeah, we're adopting, you know, the ISO standard. We've been retrofitting, you know, 1 equipment this year. We're gonna retrofit 2 next year. So it's part of you don't need to start with 1 equipment, see how it goes, you know, try it, and from there you have a good example to show your management team, to show your investment committee that, hey, listen, you know, it's working. We have less maintenance. We're reducing the exposure to the employee. We're reducing our liability over, you know, sometime 10 or 20 years, because some of those occupational illness will come down the road and will cost, you know, could cost millions of dollars to your business. So it's of course, you do it for values, you do it because you want to reduce exposure, but you have to take all of that into account when you're asking for extra budget, or you're asking for extra investment in those type of equipment. Next slide. Okay, I've mentioned it, you know, immersed, there's you know, a couple of the big players part of those discussion. It's part of the purchase specification. We've included it now at Rio Tinto in our heavy machinery equipment standard. So when we go for tender, it's part now of the standard. We're working also with our different center of excellence on maintenance and retrofitting, and the HSC people. So I'm part of the HSC function. So it's a group work. So it's not only HSC, it's not only, you know, purchasing or new equipment, it's not only maintenance. So it's a group effort. So and these different industry forum helps, you know, to promote the standard in the business and outside of the business. It could be also used in smelters, for example, in crane cabs. If you have some crane cabs above some of your smelting equipment, if you have some cabs in your cast house, so you can use this standard. It's an excellent standard to reduce exposure in cab enclosure. Of course, it's designed more for mining and heavy machinery, but what's in there can be used also at different other cabs, and I'm sure in the future we'll see that part of it. It's already being used in different industries in smelting as well. Yeah, we'll go to next slide. And we'll move to Austin, that will bring us new information on performance requirement.
Very good. Thanks, Guillaume and Jeff. Really appreciate the industrial hygiene leader perspective. So Guillaume leads the global health and hygiene function for Rio Tinto, and so he was one of 6 industrial hygienists on the 23875 committee that was able to provide a very unique practitioner-led perspective into the creation of this standard. And that's one of the things that is really unique about this standard that we're hearing from our partners around the world, is that it is practical, it is real world, and it can be implemented in the field, given the step-by-step nature of the actual document. That'll walk you through not only how to address the performance requirements, but also how to test those in a way that an industrial hygienist in the field can do the testing, not only originally, but also from a recertification standpoint. And so as we look at addressing the performance requirements, one of the things that we've spent a lot of time talking about today is more of the risk reduction. How do we reduce occupational exposure on job sites through essentially improving operator air quality? At the end of the day, all mining companies, all companies in general actually, are really focused on 3 things. How do you reduce risk, which we've covered extensively today? How do you save money? And how do you make money? The 2 other areas of that discussion, save money, make money, ISO 23875 is essential to helping as well, because ISO 23875 does allow companies to hit defined maintenance intervals, as Guillaume mentioned, around the defined maintenance intervals, ensuring that machines stay up and more productive in the field, as well as reducing the total cost of ownership. One of the other kind of unique things that we are seeing emerge is the impact on retention and recruiting, because as the workforce becomes much tighter from a labor market perspective, being able to communicate to your existing workers that you value their health, you value their well-being, not only in the short term, but also the long-term exposure, is a very good retention mechanism. And it also can be used as a recruitment mechanism to bring new employees, new workers on to the job site. The third piece that we mentioned is, how do companies use this to essentially make more money? And that is able to be done through not only hitting operating metrics, but also improving productivity and ensuring that machines stay up in the field longer, moving aggregate, extracting materials from the earth, and essentially doing the job that they're on the job site to do. And so as we think more about 2020 and 2021 in reflection, air quality is at the top of people's minds more than ever before. Guillaume mentioned that Canada still has some COVID travel restrictions. We are seeing this in other areas in which we work as well. But at the end of the day, COVID, as well as other respirable particulates that are microscopic, you really can't see them. And so there are a lot of unseen threats on industrial job sites. And these really small particles, whether they're respirable dust, nanoparticles, viruses, they can cause really big problems for companies. Big problems from a health and safety perspective, big problems from a occupational hygiene perspective, and at the end of the day, big problems from an operational productivity perspective. And so we're going to walk through how can you tactically meet the performance requirements outlined in 23875. As we walk through these different systems, note that there are icons in the top right-hand corner, and this is where we'll actually be referring back to the specific engineering controls as well as performance requirements identified in the standard. One of the first ways to address both CO2 levels as well as cab pressurization is to ensure that the piece of heavy machinery has a fresh air system. Fresh air systems essentially provide enough fresh air intake to exchange the air inside of the cab to maintain proper CO2 levels if that cab is properly sealed. Whenever you go to install this type of system, we recommend that it is keyed to the actual key switch so that as soon as that machine turns on, the pressurizer or fresh air intake is pressurizing the cab so that you're meeting that requirement to maintain essentially protection of the air quality as soon as the operator is there. regardless of whether the heating or AC system is being used. A couple of other things that we recommend as you're evaluating fresh air systems is really look at the type of filter being used. We'll spend a little bit more time on filtration specifications, but at this point, look at the sealing mechanism. You've got to make sure that there is a very tight, very efficient, high fidelity seal so that no air can slip past the filter. Because when you have that type of filter bypass, that means contaminants can go downstream, get into the cab and into the operator's lower lungs. And then the last thing to really make sure that you're looking for whenever you're evaluating fresh air systems is to look at filtration that is classified under ISO 29463. And so the 23875 standard specifically calls out either an ISO 15E or an ISO 35H filter. These are very high efficient filtration medias that will allow your team from an industrial hygiene, from a maintenance, from an operations perspective, to arrest smaller, finer particulate as well as nanoparticles on a job site. The other item to look at that goes hand in hand with fresh air is recirculated air. The operator cab on heavy machinery and fixed plant is actually one of the most cost-efficient places on an industrial job site to maintain permissible exposure level limits. If you outfit with a fresh air intake and recirculated air system, you're really protecting not only from air coming into the cab, but also once the air gets into the cab. So some people might ask, well, if you've got fresh air coming into the cab that's been filtered, pressurized, and cleaned, how do contaminants get into the operator cabin? Every time that machine operator either opens the door, sits on the upholstered seat, and a plume of dust comes up, you'll see a rapid spike in particulate in the cab. ISO 23875 has outlined specific requirements on how quickly you need to return those levels to a safe level. And you can do that through a high efficiency recirculated air system, because some of the challenges with direct from OEM systems, the filters for recirculating systems are not very efficient. They can be, very porous and let a lot of dust, debris, and other particulate through. And so it's essential that you, look for a high efficiency filter, not only on the fresh air side, but also on the recirculated side. So we've spent a lot of time talking about high efficiency filters, but what does that really mean? Anecdotally, there's been a lot of misconceptions on, what is a HEPA filter? At the end of the day, a lot of people use an old rule of thumb that, as long as it's 99.97% efficient at 0.3 microns, then it's a HEPA filter. Unfortunately, that's not the case. That used to be a standard. That classification has been withdrawn. And now we're actually using, and the standards community is referencing something called a most penetrating particle size. And that's under ISO 29463 and EN 1822. So when you're evaluating HEPA filters, it's really important that you push past the 0.3 micron efficiency and ask for the MPPS, or the most penetrating particle size, because it needs to meet the requirements. And the Sy-Klone HEPA filters are 99.95% efficient at MPPS. In addition, we've mentioned COVID-19 and the impact on the industrial work site a couple of times throughout this presentation. The new Sy-Klone filters are actually 99.95% effective at stopping COVID-19 sized particles as well. So in addition to the occupational exposure reduction benefit of ensuring dust and debris stays out of the cab and out of operators' lungs, there's also a benefit of reducing exposure to airborne viruses, not only such as COVID-19, but also influenza. The fourth part from an engineering control standpoint that the standard calls out is real-time cab monitoring. As you're evaluating options in this front, it's really important that you look for a monitor that not only assesses pressurization, but also CO2 levels. As you're evaluating a CO2 monitor, it's really important that you dig deeper to not only say, okay, it's a CO2 sensor, but also what type of sensor is it? ISO 23875 calls out a specific sensor due to the high accuracy real-time nature of the data that it reports. And so not all CO2 sensors are created equal. It's really important to dig in and understand what is in the box, because the box that is a monitor is essentially a very good mechanism from a short-term safety control that can alert heavy equipment machine operators on the air quality condition inside of the workspace that they're spending 8 to 12 hours in a day. And so this is a good mechanism to not only be able to alert from a visual standpoint. You'll see that the example here, the Sy-Klone Respa Advisor, has green for good levels of cab pressurization as well as CO2, but it will move to yellow and then red whenever it gets outside of the permissible limits. But per the standard, there's also the requirement for an audible alarm so that you have multiple levels of communication and alertness to the operator when conditions are no longer safe or outside of the realm of the defined limits. So before we move over to a question and answer period, I did want to share 2 case studies. The first case study I'm really excited to share. This actually comes from Eastern Canada and was the first ISO 23875 installation that was certified using the performance test requirements as well as delivered on site and is now in service. This CAT 992K was an installation that was delivered. It was a retrofit done by Climatrans out of Montreal, and Climatrans was able to work with the local mine site to, as they received this new machine from a tender perspective, they were able to equip it and essentially ensure that the cab was ISO 23875 compliant before it went into service. One of the interesting things and kind of the most impactful thing from the Climatrans team is that they shared, this is very feasible. Given what is outlined in the standard, it outlines step by step every part, process, piece along the way that an industrial hygienist, a partner, a maintenance provider, a service provider can do to implement, stand up, and deliver ISO 23875 certified solutions. So the CAT 992K was actually able to, exceed the performance testing requirements from a pressurization standpoint. The pressurization requirements, if you'll recall, that Jeff outlined, is it has to be higher than 20, but no higher than 200. During the multiple levels of test, the actual performance was between 88 and 115 pascals from a pressure standpoint. So it was right there in line. Being able to use not only the Sy-Klone fresh air intake, but a recirculation system coupled with high efficiency filters on both the fresh air and recirculation side was able to create that ideal pressurized environment. And something that we haven't really mentioned, but pressurization is essential to keep dirt, debris, and harmful respirable particulates outside of the cab and keep the air quality inside of the cab pure and safe for the machine operator to breathe. The other test that the mechanism passed was the decay time, and this is a test that we mentioned when walking through the recirculation. And so the decay time test started at 5,000 micrograms per meter cubed, and it was able to get down to 50 right within the actual kind of actually below 25 per the standard within 100 seconds. So that is 20 seconds faster than the requirement. And then the last test from a CO2 test, the CO2 requirements call out ambient, which is the environmental CO2 plus 400. So the ambient CO2 concentration on this site was 320. When you add the 400, it gets to 720. This installation actually averaged right at 500 parts per million from a CO2 test performance, allowing this to be certified as a 23875 compliant installation from an air quality standpoint. And before we go to Q&A, one last case study wanted to share. This was an interesting case study that Guillaume mentioned earlier in the presentation. And this was looking at a mine site in northeastern Canada that was dealing with a specific challenge around addressing a fibrous substance So this can be, a quite challenging work environment, not only from the respirable particulate in the air, but also from the working conditions. And so this was a head-to-head test where the down the hole drill on the top was equipped with the OEM pressurizer, whereas the down the hole drill on the bottom was equipped with the Sy-Klone RESPA system, Sy-Klone filtration, as well as Sy-Klone recirculation system. As you can see, the drill with the OEM pressurizer was never below the red line, which was the permissible exposure limit level. However, on the bottom, the Sy-Klone system, after some initial spikes, was able to recover that air quality, keep it well below the permissible exposure limit, with the exception of when the actual operator opened the door. And as you can see, as the operator opened the door and shut it, the recirculation system combined with the high efficiency filter was able to quickly recover that air quality and bring it back to normal. And so with that, I'd like to welcome Jeff and Guillaume back to the conversation. We see quite a few chat questions coming through the portal, so looking forward to a really good conversation. But before we do, I did want to just thank again the sponsors for today's session, Climatrans and Polar Mobility, in association with ICE, Sy-Klone, and CIM. So now I'll turn it over to Ryan for the Q&A session.
First, before we do the Q&A, we're going to launch the poll. Okay, here we go.
And while people are doing the poll, just a quick acknowledgement and on one of the example of the case study that you presented. I know Karen Morin is on the line right now, and she worked really hard and worked really with the people of Climatrans to achieve success in one of those projects. So thank you, Karen. And that's when you involve the local team, you can achieve very good results.
All right, great. Well, thank you all for that presentation. So yeah, just a reminder to attendees to type your questions into the question box in your go-to webinar control panel. Now, first question I have is for Jeff. What about radioactive particles from mining rare earths, uranium and thorium?
Great question. Yeah, the issue around radioactive particles is the same as any other type of respirable particle, except for it's got a radioactive isotope attached to the particle, which makes it even more dangerous. But it's a particle, so it gets back to the level of filtration. When we decided to go with ISO 29463 as the filtration classification system and testing system that or standard that we would use or we would adopt in 23875. It was specifically to address this kind of problem. As Austin mentioned, these are very, very small particles like the COVID virus, which are also particles that are very small. And we have in ISO 29463, if you use the ISO 35H filter, which is recommended here, in the case of the filter that he was talking about earlier, it takes out, it's essentially a 60 nanometer at 99.95% efficient filter. That level of filtration is highly effective in your radioactive world, where you've got radioactive isotopes attached to small particles as well. So how do we address the problem? We use really effective and highly efficient particle filters that are able to take these particles out of the air.
Great, thank you. So this question, I guess, is for Austin. Does the standard apply only to new equipment, and is the standard only applicable to heavy machinery?
Yeah, that's a great question. And as we look at how the standard can be applied and truly make an impact on work sites, it does not apply just to new equipment. It applies to existing fleets of heavy machinery equipment, both mobile and fixed plant. And so that's where there is an opportunity to truly protect operators across the entire fleet of machinery. And so, as Guillaume mentioned, Rio Tinto has added it to their machine spec for new equipment tenders in Australia, but there are also opportunities to work with, as the case study showed, vendors such as Climatrans and Polar Mobility on retrofit applications to really bring cabs current so that they can be ISO 23875 compliant as well.
So for you, Guillaume, how is Rio Tinto adopting ISO 23875? Is Rio integrating it into their health and hygiene programs as well as machine specifications?
So right now it's in the machine specification, but the goal is to include it also in the health and safety standards. We're just starting a review process of our health and safety standard this year. So of course it will be included following the discussion that we have internally. But yes, it's a long process because it's changing standard in large company are not just that easy, but so we have people like myself and other people in Rio Tinto that believes in the standard that going to make sure that it's included in the different new version of standards.
And so I've got a follow-up for you, Guillaume, which is you mentioned a bit about your implementation success in I assume somewhere in the Labrador Trough. What practical advice do you have for your peers starting out on this journey to introduce and adopt ISO 23875?
But start small, start with one piece of equipment, involve like the industrial hygiene, the maintenance, and involve people like Climatrans or people that have the expertise, that have done it elsewhere. They will come with you with good solution that they've tested elsewhere, and start with one equipment, and include a full team. So I'm not like a big believer of let's do everything at one shot. You start with and then you show. It's like a showcase that you can show the rest of the business that it's working. And one of the example that Austin talked, there was a paper that was published in one of the CIM journal that explain in more details all the work that's been done in terms of implementing the standard in a couple of equipment.
Great. Well, thanks for plugging CIM journal. Appreciate that.
Yeah.
Yeah, this question is for you, Austin. How are CO2 levels measured?
Yeah, that's a great question. And one of the things that the standard looked to do is, measure things in a way that industrial hygienists in the field could do that. And so, the way we're measuring CO2 in the cab is using the RESPA Advisor Plus, which is a new in-cab monitoring solution, which, features that ISO 23875 compliant dual infrared CO2 sensor. And it might feel like splicing hairs, but it is really important that you have those types of high quality sensors so that you can have not only comfort and confidence in your data, but you're getting high fidelity readings in a real-time setting.
And Austin, also, is this standard limited to mine sites and the mining industry?
Yeah, that's a really good question. Something that we hear a lot. And so, although it originated in the mining working group, it has actually been applied across industries and has been appended to focus on operator enclosures, not just operator enclosures on mine sites. So this is kind of a practical play-by-play book for mine sites to use to drive compliance, but other industries can benefit as well on both fixed and mobile. And we also see, companies using this in things like operator control rooms, so for large rock crushers, because those employees are exposed to, the harmful particulate, just as if they were behind the, wheel of a wheel loader or an excavator.
Yeah.
For you, Jeff, how is standard compliance certified? What are the testing requirements of the standards?
I'm sorry, if you could say that again. I'm not sure I understood the question.
How is compliance certified? What are the testing requirements of the standard?
Right, good. Yeah, thank you. Great question. We have a series of things that are shalls, that is requirements for certification. They involve the engineering control requirements. So the way the standard is set up, it says these are the things that you shall do as it relates to specific controls on the cab. Once those things are implemented on the cab, and you can check the box that if it says I'm going to provide, this level of pressurization with this in a way that's acceptable to standard, I can check the box and say I've completed that. When you get to the end, you take a test, and that test is an actual performance test that was designed, by the way, not to be a laboratory type test. It's a very practical test that can be done at the OEM level or as a retrofitter out in the field. It was designed to be very real world in the way that we approach it, both in the cost of the instrumentation to do the test and the means to do that, as well as the whole method. It's very simple. It's designed to give you an indication that your engineering control installation has been effective. And that's the purpose of the testing. Once the testing has been done and you validated that your engineering controls are doing what they are supposed to do, then the next thing that is done is we look at the operator's maintenance manual, and there are specific requirements about what has to be in the operator's maintenance manual. Those are spelled out in the standard very clearly. Once again, the handoff, which is going to take place once the retrofit is done and the initial testing is done, is going to be to an end user who's got to take that and maintain it for the life of the machine. So we're very concerned that the maintenance manual have clear instructions about how that machine is going to be maintained so that it can be maintained in the future. So once all those steps are done and you can check the boxes and say we've got all the shall requirements completed, then you can do a certification. I would suggest anybody that is really wanting to learn how to do this, there is a class that was put out by ICE. It's an online class that you can take. It will absolutely get you to the finish line the quickest way possible about understanding this process. It's a great question. If you want to understand it and get templates that give you the checklist, a templated form of the operator's manual is in there as well. You can go to the ICE website. My email is there. It's isee3.com or iceeee.net. Either one takes you to the same place. And you can look at the class content. And I would recommend if you're at IH and you want to understand how to audit this process, you really should take a look at this class. ICE is an international 501c3. We're about promoting 23875 as a means to improve operator air quality and preserve the lung health of operators. This online course is designed to get you up to speed quickly on that question. What is required and how do I go about doing that efficiently? So that would be a way to do it.
Okay, great. Question for you, Austin. Is this standard adopted by mining equipment manufacturers at this point?
Yeah, we're actively working with multiple OEMs at how do you address OEM kind of first fit factory solutions, so that as companies, as end users are updating their machine tenders and having new machines spec'd and delivered on site, I can either be delivered as a first fit with the 23875 compliant cab, or you can opt to work directly with a local vendor such as a Polar Mobility or a Climatrans to retrofit those machines as they're being brought into service.
Great. Well, I think we have time for just one more question, and maybe this one for you, Guillaume. I know that Austin had touched on it a bit about just some of the other benefits of adopting these standards for the workforce. But I was wondering if you could maybe give your perspective as an operator on, sorry, let me just summon the question here. Just the additional benefits beyond the health and safety aspect of adopting such standards in the workplace, and I guess it's
we've talked about health and safety improvement, we've talked about maintenance, and we've talked about cost reduction, but it's also being part of doing the right thing, being a leader in the industry, and I think personally, I think it could be a breakthrough in terms of exposure. We still have some cases of silicosis, we still have some cases of cancer, so those type of standard can really be a breakthrough in terms of protecting employee, because we know that PPE doesn't work that well. So those type of engineering control and the technology will evolve, you know, and maybe in 20 years everything will be remote like a Tesla, but right now we're not there yet. So those equipment we need to be leaders and to show that there is new technology and we want to use it and implement it as leader and doing the right thing for the industry.
Great, thank you. Well, it looks like we've run out of time. The questions that we didn't get to will be forwarded to the panelists. If you have any further questions, you can reach out to either Jeff or Austin. Their contact details are listed there on the screen. And thank you, gentlemen, for doing this. It was very informative. Appreciate it. Over to you, Michelle.
Thanks, Ryan. And thank you to Jeff, Guillaume, and Austin. I'd like to thank all of our attendees and ask that you please fill out the short survey that pops up on your screen at the close of the webinar. A link to the video recording of this webinar will be emailed to you tomorrow, and we hope to see you at our next CIM Magazine Solutions Exchange webinar. You can find a listing of the latest CIM virtual events on our calendar of events at cim.org. Thank you, everyone, and goodbye.
Thanks, Michelle. Thanks, Ryan.
Thank you.
Thank you.